I'm feeling nice today.
I started with the ending and ended with the starting. Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 96. Today we're talking about a Diaphragm engine, a DIY dishwasher, some forgotten Soviet computers, and a Starlink teardown. Elliot, the right to repair bill was approved by the European Union.
Yeah, I read about it on Hackaday.
I'm excited about this. I'm glad that Jenny grabbed it and wrote it up. She has done a good job of chasing down right to repair topics from the past. And this one's interesting because it recommends a mandatory label on products that will give them a score on how repairable they are, which is an interesting take on it.
I think that's awesome. I do have to wonder who's going to be doing the scoring and what it's going to mean. Because going on parallel to the EU's movement, there's one going on in the UK right now, and they just put out their findings and, for instance, dinged Apple extraordinarily heavily because when the iPhone breaks, you have to take it to the Apple store, and often it's so expensive to get it repaired. Everybody gets a new one, throws the old one away. Is that a high repairability score because it's easy for you to just walk into the Apple store and give them money? Or is that an incredibly low repairability score because nobody does it? So there's going to be, this is going to be devil in the details. I can feel it.
I think that it's promising that the topic is being discussed publicly. Absolutely. And that there's some movement on it. But you're right. Like, implementation is not only difficult, but so far undetermined.
But I think this is something that everyone cares about. Like, all consumers care about keeping their stuff running. And so it's a great step forward, even if it's not going to be a perfect solution. It's probably a step in the right direction, and it'll put some pressure on people making stuff to think about how to get it repaired.
But of course, when it comes to things that can't be fixed, Arecibo, unfortunately, has collapsed under its own weight. Regular listeners of the podcast will know we've talked about this for the last 3 weeks. There was a cable that snapped after previous damage hadn't been repaired, and then the NSF said that they were going to decommission it. Well, I'm not sure what day it was. It might have been on Tuesday this week. And there's some pictures out there that are pretty interesting to look at. The transmitter receiver, which was suspended above the dish, came crashing down. Boy, if it wasn't a total loss before, it certainly is now.
Yeah, we were talking about that among ourselves in Hackaday's secret lair, and Tom was saying that he heard that there might have been an earthquake just before the collapse, and we don't know if they're related, of course. There's going to be some engineering post-mortem going on, and when we hear some more details about that, I'm sure we'll write it up.
On happier news, the Chinese Space Agency has landed... Is it the Chinese Space Agency?
I don't actually know what they're officially called.
Yeah, I don't know either. Anyway, the Chinese Space Agency, which is what we're calling it for now, managed to land Chang'e 5 on the moon, which is going to collect moon rocks and hopefully bring them back to Earth. I think we'll find out this weekend how the blast-off went.
Yeah, that's the hard part, and we're all like crossing our fingers for them. I hope they could pull it off. It's really kind of fun. I like the idea of just sending, relative to a Mars probe, the moon is extraordinarily close. Like, it's only a few days flight time, right? So anyone could just send up a little robot, grab some rocks, and fly back to Earth, right? How hard could that be?
Well, and the funny thing is we were talking about it in a pitch meeting this week. I think Tom is actually going to work on an article that kind of covers the whole mission, how it went, how it got put together and everything. But all of us took a pause, I should say, when we found out that it's only going to be on the moon for like a couple days. Like, it feels like a very quick trip, but when it's just a robot on the surface of the moon and it has limited carrying capacity, what else is there to do other than land, get your samples, and leave?
Yep, put down, do a little bit of science, get the heck back home before some micrometeorites hit you or whatever.
Well, let's jump into the hacks, Elliot. What do you have first on your list?
Okay, first this week is Tom Stanton's video on his new Diaphragm air engine. And Tom's probably one of my favorite YouTubers. Yeah. He does some crazy things and then explains them extraordinarily well. He's kind of been fascinated with the old 1990s Air Hogs toy, which was a pneumatic. You put air into basically, it looks like an old soda can, and then it spins a propeller and it flies. And he's been trying to recreate this a number of ways over the past couple years. And it's gotten to the point where he has, as far as I know, invented his own kind of high pressure air driven engine. And that's what this video is about. As the crankshaft turns, a little pin pushes up a check valve, which lets the pressurized air into a chamber. This then pushes against the diaphragm in the name of it, which pushes the piston back the other way. There's a little hole in the diaphragm and then a pin that pulls out of it at the very end of the stroke so that the air can flow all the way through the rest of the engine. But what's neat here is that if you think of a normal internal combustion engine, it's that explosion that drives the piston back and forth. And here it's just the force of that compressed air in this forward chamber as it's being let in, and then that little valve closes, and then you've got all this compressed air. It's pushing the piston out the other way, doing the same thing as the explosion in an internal combustion engine, except it's all just air pressure.
I got to say, you're right. When I saw this was on your list, I was like, yeah, Tom Stanton has Elliot's number. But
yeah,
at the same time, he's got my number too. How can you not watch these videos and be incredibly impressed? And he does an amazing job of showing you diagrams of what's going on inside of these different piston designs that he's put together. So it's really easy to understand. For me, it's difficult to understand how a constant pressure of air can be turned into that rotary force. And so these do a really good job of showing you the different pressure chambers and how pressure is exhausted out on one of the swings of the piston. And I think that is, exactly what I needed. I wasn't familiar with the air hog, so I didn't even know that these existed before this.
Yeah, I mean, they exist, but they use a much less sophisticated kind of air-driven engine. And so he's basically trying to improve on it. And I think he's going to. In addition to being kind of a fully 3D printed design, which is how he gets those awesome animations to show it working, because, he's got the 3D model anyway. It's just like, run the video and you can see how it goes. But in addition to these awesome 3D models, I guess he's got a custom cut diaphragm in the middle made out of some kind of rubber. And he's also tossed on a gear set to this thing. I do a little bit of model airplane stuff. I started actually this summer, and he has, I'll say it, he has absolutely the sexiest carbon fiber propellers I've ever seen attached to this thing. He's very serious about this, and if he's not able to get this thing flying for a long time on just the compressed air in a 2-liter, 1-liter bottle, I will be surprised. Why would you want to do this? This came up in the comments. Why don't you just shoot the air real fast out the back like you would with a rocket? And one of our commenters, Paula, absolutely nailed it. This is essentially an impedance matching problem. You've got a small amount of high pressure air and you want to turn it into a force over a long time. You want to move a lot of air at not very high pressure for a long time. So it's an impedance thing. So you have to kind of figure out a way to gear it down. And that's what Tom's motor is doing by letting a little puff of high pressure air into the small chamber and then having that do its work. And then that turns something that turns a gear set that then turns this giant propeller that moves a lot of air, but with a lot less pressure. And this hopefully will have him running his plane for, I don't know, a few minutes on a pump. I don't know what his goal is. I see you've got a note that timing is bizarre.
Yeah, the mechanical timing problem on this is just awesome to watch him work out, because it has, I don't know if you can call it 2 cycles. It has kind of 2 valves in it. And so there's like an intermediary chamber, and there's a pin attached to the head of the piston. And so when the piston rises up towards the inlet of the air, it pushes like a little BB out of the way, letting the pressurized air into the first chamber. But while it's in that position, it's also closing off the second chamber. And so on the downswing of the piston, it opens the second chamber, and the length of that pin where it moves the BB and where it unseals the second chamber is what decides whether it's going to like ka-chunk, 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 or purr like an engine. And you can see in his face when he gets it to actually turn and self-sustain for the first time that he's put a lot of trial and error into that mechanical timing that can't be very easy to adjust.
What's funny about this is, of course, it's exactly analogous to the way like an internal combustion engine works. You have to squirt the fuel in the right time, and then you have to explode it at the right time, and then you have to exhaust it at the right time. And he's doing all that, except all of the timing, instead of being, coordinated by cogs or electricity or anything reasonable and easy to adjust, is the length of this pin that opens up the high pressure valve, and then the length of this funny machined brass collar he has that blocks the hole in the diaphragm for the exhaust on the other side. Getting those right means you can't just, turn a screw to advance your ignition timing. You have to rebuild this part with slightly different lengths and ratios of lengths to each other and try it out till you get it right. So kudos to him for having the determination to make it work.
Who put the caption on the GIF in the article that says this GIF is worth 115 words? Was that Danny?
It must have been, yeah.
That's such a great caption, and it is. You should go look at that. First up on my list this week is an incredible teardown. We could call this the teardown of the year so far, I would say. The Starlink antenna, which is SpaceX's satellite internet program, has started to roll out. And so you need a little satellite dish that's a couple feet across in order to get your high-speed internet from space. Wahaha, space. And in this case, I am shocked to find out that Kenneth Kiter was willing to buy one of these and destroy it just so we could see what's inside of it. But I'm incredibly glad that he did, because it is, mil-spec hardware. It's incredibly highly designed and intricate and amazing.
How much do these things cost?
$500.
Yeah, you wouldn't expect it to be anything less. No, it's an amazing piece of engineering.
Oh, yeah. When you have to make sure that they work really well out of the gate, or the whole Starlink program is at risk. And so really, the cost of these, designing these and manufacturing the first round of these doesn't matter, as long as it works fantastically. And then you figure out from there how you can do it at scale.
So we got to step back and say what's interesting about this thing, and that is that unlike most satellite dishes you're probably thinking of, it tracks the satellites by beam steering. So it's got a whole bunch, I'll have to look at the number, 632 little elements, and you use the phase shift in between those to figure out where the satellite is that you're listening to and transmitting back to. So this is a beam steerable listening and transmitting antenna. It's a pretty amazing piece of gear for $500. I'll give that up.
Right. So phased array is what does the beam forming. And those 632 elements are chips. And so this is a huge, 2-foot diameter satellite dish sized circuit board with 79 blocks that have 8 of these elements in each of them. With at the center of it, it looks like a low frequency clock signal that feeds all of them in order to synchronize them up. And then, because the best place to get hard data is Reddit, I went out and found a Reddit comment that did some math on how fast the Starlink satellites are moving overhead. And it says the spec that, again, Reddit comments, so take it with a grain of salt. They say the spec that was given to the FCC was that there was going to be a 3-degree area where you could communicate with the satellite, and the satellite leaves that 3-degree area every 2 seconds. And so you have to be tracking across the sky constantly with these. The satellite dish itself does have a mechanical gear component, so it can point the dish, but the fine tuning is being, in order to track across the sky, is being done with the phased array.
What I thought was really crazy about this is at one point Kenneth mentions that this thing, when it's running, it has a thick Ethernet cable, a thick special Ethernet cable. And it's thick because it's doing power over Ethernet to the thing. And it's consuming 100 watts actively while listening. Heat your house with one of these.
Oh, right. Maybe they could make it a water heater hybrid.
You could. No, but it's obviously doing a crap ton of processing to get all this beamforming stuff done. But the fact is, it has to have a special Ethernet cable with extra thick wires in it to be able to run the power over Ethernet at such a high wattage.
Yeah, pop some popcorn. This is a 55-minute video or an hour-long video or something like that, but very cool to watch. And I was excited to read in the comments. I saw Mike Harrison and Mike's Electric Stuff said, hey, you need to send this to Sarir from the signal path because he'll be able to reverse engineer all the RF magic in there. And then Sarir got on there. And so Kenneth and Sarir are in communication, and Kenneth has shipped this to him. And so Signal Path is going to have a good video coming out on everything that's going on under the hood with this one.
So from high tech to extremely low tech, Billy built himself a dishwasher from scratch, and we covered it. I wanted to talk about this one because I thought it was I think it's charming to try to reproduce yourself a large piece of home electronics like a dishwasher. There's a lot of things that have to go on there, and maybe you don't appreciate it unless you've tried to take a dishwasher apart and repair it, or in this case, build your own. Billy started off with an idea and basically prototyped it as quickly and easily as he could. He had a pump. He had a lawn sprinkler to do the spraying. He put it in a plastic box, sealed it up, wanted to see if it could take heat. So he poured in a lot of hot water and he ran it. And, he discovered a bunch of things along the way, like his jet wasn't fast enough and, it wasn't knocking rice grains off of his dishes and stuff like this. Fast forward a year and a bit later, and you end up with the final version, which is in a second video attached and also in his write-up. He's handled the pressure problem. He's added a water heater so it can heat the water up itself. It's got a bunch of valves for filling and draining and things like this. And it's all run off of an ESP8266, which I guess in principle could make this an IoT dishwasher if you wanted to. I don't think he's using the Wi-Fi functionality at all, and he's just using it as a CPU basically. But I think it's marvelous to think about designing your own quasi-industrial machinery like this, because it's in some sense a really simple problem. It's just get this sequence right, get this sequence right, get this sequence right. If this happens, then this. But then you have to think about all of these little details, and there's a lot more going on in a dishwasher than I think you think.
Well, yeah, it's master of all domains, right? I mean, you've got electronics, you've got plumbing, you've got driving motors, you've got little mechanical design in what shape of the sprayer that you're going to use on this that goes around. Yeah, I think it's a wonderful way to kind of get yourself up to speed on all of those things at the same time. It also, it makes you really appreciate the things that are built so simply that they perform complex tasks.
There's one thing that's missing from this that's super important to a dishwasher that I have to bring up. Yes, soap. He adds soap. That's no problem. No, it's a filter. So if you think about the way a dishwasher, like I'm actually a pro hand washing, because when I wash things by hand, I know I'm getting that dirt off and I know where it's going when I rinse it. Whereas a dishwasher just kind of fills up this pan and it sprays the same soapy, dirty, hot water over your plates for a while, hoping that eventually they get clean. But while it's doing this and the rice is falling off of your dishes down into this water, an important part is this filter that then keeps you from getting those rice grains back into your pump, gumming up the jets, gumming up whatever else. And I didn't see how he had a solution for that here. And I think that's going to be, if he ends up using this more than a few times seriously, he's going to discover that he needs an inlet filter. But that's the beauty of a project like this, is that you get to say, what is a dishwasher doing from the bottom up? And I don't know. I just love the effort, and I love the fact that he documented his prototype and then all the way along.
All right, if you're looking to do software-defined radio and you want to up your hobby game a little bit, you probably pick up the HackRF because it's good and it's reasonably affordable. But the one thing that is not great about it is you have to connect it to a computer. That is, unless you have the PortaPack, which puts on a screen and some user buttons and does things like audio out for it. This is a really awesome kind of all-in-one package you can take around with you to do a lot of different tasks. And now even more because there is a new firmware out for it called Mayhem. It's a fork of another firmware that was made custom for the PortaPack that has been since abandoned. And this takes the torch and it runs with it. And it's pretty incredible to see what this can do. It has numerous protocols like ADS-B, SSTV, POC-SAG, which is for a lot of pagers. There's RDS, which is the information that you get up on your FM radio. It can record signals and it can play them back. It can store them on SD card. There's a ton that you can do here. It even goes into, it's got the term mayhem. It goes into being able to do denial of service, basically like jamming. We hope that it's doing that for people that are doing testing and interference hardening on their own device rather than actually being up to mayhem. But it takes something that's available at a reasonably hobby level of prices, and it really fast forwards what you can do based on just building up better firmware over years of work.
Yeah, you look at the specs and the protocols that this new firmware covers and everything. It is absolutely stunning. I've played around with software-defined radio in a couple places around our house. Like, we have some of those external thermometers that, sit outside and use 432 megahertz to talk to a little unit that sits on your desk and tells you what temperature it is. And we've got a garage door opener, and we've got, this, that, and the other all around the house. And I've played with them with normal SDR tools like an SDR dongle or actually the radio badge from Chaos Camp years ago. Like you said, you have to be tied to your computer for them. And that really is, it's a lifestyle issue. This is like hashtag first world hacker complaints, I guess. But it's a pain in the butt to have to drag it all around. And you've got this wad of cables. And so I look at the PortaPack, and actually Jared's original PortaPack design was brilliant for just that reason. And then this just seems to be loading it with every possible protocol you would ever care to snoop upon.
It is crazy to see how far this has gone. I will put this link in the show notes. Brian and I were at DEF CON 22 and sat down and had lunch with Jared Boone, who built the original PortaPack. And he gave us a whole demonstration of what was going on, like at the table. This is back in 2014. And I think it's still just as relevant in the Hacker Toolkit, and with the help of a good group of open source firmware developers, it's getting more useful by the day.
And speaking of crazy radio hacks, Jacek has a hacky hack leaking data slowly by switching Ethernet speeds. We put a link into the fourth in this series of explorations of his, but all four of them are worth looking at. The idea is, imagine you have some need to get data out of a computer through clandestine methods. So this is data exfiltration, and you have control over an Ethernet port, but you don't want to just send the data out because that would look super suspicious. What he does is he switches the speed between 10 base T and 100 base T that the device is using for its Ethernet. And the different spurious radiations that these put out, which I guess is like 125 megahertz at 100 base T and something like 10 megahertz at 10 base T. Don't quote me on that. But you can use these two different, wildly different frequencies for some kind of frequency shift keying setup just by controlling the data rate that the interface uses. And what's funny about this is when Ethernet isn't transmitting, it kind of has a null string that keeps repeating. And this is what makes this nice, long, reliable sequence. So you can change the speed of the interface, and that will put out, a different bit, either the high frequencies on or the low frequencies on, to the outside world, to someone snooping in with an SDR or something. But you don't actually have to transmit any data over the interface at all. You're just having it idle at these two different speeds. And I thought that was really clever because, again, think about what kind of intrusion detection tools would be looking for this. Absolutely none of them. So it's a super clever way to exfiltrate data.
At a really slow bit rate, like almost unimaginably slow.
It depends on which version of his hack you're looking at, but go ahead.
I think you need to take your PortaPack to the office and have your friends in other cubicles set up a Morse code messaging system based on this.
Yeah, see? Yeah, so he looked into this a couple ways. The slowest of them all was the one we linked in the article, which is the fourth experiment, where he has 2 Dell laptops on a table and a really good quality shielded Ethernet cable between them. He's surprised that he can still get some signal out of this thing at all, but because of a limitation with the Dell's hardware, they can't actually switch between the 2 Ethernet modes very quickly. And so this is the one where he's stuck with a ridiculously slow data rate. In the other extreme, he tries the same trick on some Raspberry Pis, and they can switch between 10 and 100 base T really quickly. And so he's able to get super fast information out of those. And along the way, he was like, this is working extraordinarily well. And he unplugs the Ethernet cable and checks if he can do it with absolutely no cable in there. So part of the idea, of course, is that the cable, if it's not perfectly coupled with everything, if it's not impedance controlled all along the way, et cetera, it'll radiate some of this extra energy out, and you can pick that up with a radio somewhere. It turns out, even without this effectively bad antenna, the Raspberry Pi 4 is so noisy in switching between the 2 data rate modes that he can do it without any cable in there at all. And then last up, I guess, is my absolute favorite of these because it's the one I expected the least. He modulates the Ethernet carrier frequency by sending more data or less data. And this doesn't work on everything, but he noticed on some devices, if you really hammer it with a lot of data, it may be their power supply isn't quite up to it and the voltage sags. The frequency at which it runs would slow down a little bit. And so he could get it to go just a tiny little bit of frequency deviation just by overloading the interface or not. And I thought that was a hyper clever means of sneaking data out. I don't know. I just love Tempesty kind of methods, and I'll throw a link to an old write-up about all sorts of things Tempest if you're interested in snooping in on the inner world of your electronics by radio means.
Well, there's no hack on this last one, but you're definitely going to want to come along for this abandoned exploration as urban explorers reveal a treasure trove of Soviet computing power. This is a random building in a random business park somewhere in the former Soviet Union. And some explorers got in there and found in one floor of the building a completely intact computing center. And this is the old stuff. So it's not going to be things that you've probably heard of before because it's not the Western computers. This would be the computers of the Soviet Union, mostly DEC machines that are kind of clones of some of the ones you've heard of. The most famous would be the Saratov 2, which would be something of a PDP-8 clone. But there is a lot of stuff here, and it looks like what happened is at the fall of the Soviet Union, the people that were working there just put the dust covers on these racks of computers, shut the lights off, and just didn't return.
I love the pictures out of this. As a kid, my dad had in his lab a PDP-8, and when they retired it, it lived in our attic for a while, so I've played around with it. The Russian PDP-8 clone that they have here is amazingly similar. Like, the cards in it have those same funny little rack ears on them as the cards on a PDP-8. It's exactly the same thing. Unfortunately, the little flippy switches aren't the same color and stuff. So if you're really, into your PDP-8, you'll be like, oh, it doesn't have that same feel that the old DEC ones did. On the other hand, their rip-off PDP-11 looks a lot sharper. So go Russian copying tech of the late 70s and early 80s.
Yeah, and I can't complain. I mean, Ralph Miribs, who's the copyright name on all the photos, did a great job of showing all this equipment, but I just want more. Like, at some point, the write-up mentions magnetic memory, which I assume is core memory, and you can kind of see it, but it's not a very close-up image. And I'd like to see more detail on that. So these would have had the core memory and then the punch tape that they would have read in for the programs. There's, some of it does look like it's been sitting well cared for on a shelf. Other parts of it must not have been covered because it's black with soot. There's an almost a Commodore looking keyboard on one of these, and you can't even read the letters. It's just so black on top of it. It sounds like there might have been a fire in the room that was put out before it got to the computer equipment, so there might be some fire damage on this stuff. I did find it amusing that they have a computer that it looks almost like an IBM with the 5.25-inch floppy drives on it, but then one floppy drive has been pulled out and then a 3.5-inch drive has been put in, but there's no like faceplate or bezel. It's just kind of sitting in the black hole where the larger drive used to be. And just stuff like that really makes me follow my mind's eye into what it must have been like for people to be working in this computer lab at the time, and especially at a time when computers were, still quite rare, and especially this many in one place, and having someone that knew how to use them. It's an interesting snapshot into a time gone by.
Starting off my quick hacks this week is Mark Aaron's building a vector graphics machine from scratch, including the CRT. This is a lovely imagination of a vector computer. He goes into all the details you'd want him to go into if you were interested in building your own CRT vector machine, including, what's the right voltage to run on, how to do the wiring harnesses, details about running the DACs just right. If you're interested in this sort of do-it-yourself from the ground up retro computer building, this is the article for you. On the other hand, if you're into FPGAs, Ultra Embedded's Pushing the FPGA Video Player Further is an absolutely marvelous collection of kind of VHDL snippets and codes for doing video manipulation with FPGAs. Again, not everybody's into this, but if you are, here's some code you should absolutely look at for including in your own projects. And last but not least, here's something that nobody has any use for. Jeffrey's mouse-controlled mouse controller is silly, but could be useful. I don't think it could. This was an entry into a useless machine contest, and basically it's a 2D plotter. Instead of having a pen, it's moving a mouse around. And then, of course, he's controlling the thing with a mouse. So he's mousing, and then the machine mouses with the other mouse. It's absolutely marvelous. I have no idea why you'd want to do it, but watching it go is half the fun.
First up on my list of quick hacks is the MQTT dashboard uses sharp memory LCD. This one is by Raphael Barron, and I love it for a couple reasons. One, if you're not going to be using this user interface very often, it can be very low power because those memory LCDs maintain the image on the screen very easily. But the other one is, go look at this one. The rack that's used to mount this memory LCD is just a 3D printed hoop, and it looks really nice. It looks almost like 1960s stamped out of steel and then powder coated. It's a really good look and would be great on your next project. 3D Camera Motion Rig is mostly 3D printed is a project that Do It Whenever put together. This is kind of a bizarre one. It is mostly 3D printed gears doing a lot of the motion on this. It allows you to just feed G code to it, and you can do different camera movement effects with it. Very quite versatile. And then it also has manual buttons put onto it so that if you want to reposition it yourself, you can use the electronics that go along with it so that you don't lose like where you are in the homing of each part of the CNC machine. And finally, repurposing large electronic price tags. Near and dear to my heart, Yoda Logic figured out that you could get these 7.5-inch 3-color e-paper displays that were being used as price tags on like refrigerators at the Home Depot. You could get them on the surplus market, and I actually got one of these delivered for like $15.99 from eBay. I was ecstatic. He had a lot of trouble getting it to work at first. Ended up desoldering I think it's like a CC 1100 chip or something like that that's on there, and just running it with wires himself, but had trouble getting it to work and didn't know if the LUTs were right. Well, put the thing up on Hackaday.io, and along comes Aaron Christoffel, who maintains the GXEPD2 library, which if you've used ePaper on Arduino, you've probably considered using this library. Well, Aaron figured out what the right LUTs were for the yellow, the third color on this, and ended up already adding it to the library.
Quick hacks. quick hacks.
It's time for our can't miss articles of the week. This is long form content written by wonderful Hackaday authors. Elliot, you're up first.
This week I picked Lewanday's Enhance is now a thing, but don't believe what you see. And this is a good look at kind of what the state of the art is in AI reconstructions / improvements / enhancements of images and movies. I thought it was really cool. I guess he started off with the kind of old trope. I know it from Blade Runner, zoom, enhance.
Hand right and pull back. Stop. Enhance 34 to 46.
Yeah.
And he claims that you see it a lot in 1990s cheesy law enforcement movies where they take a pixelated movie, they press the enhance button, and out pops the picture of the perp in question. What's cool about this is that that's the worst possible application of this technology. And I got to go on a 10-second rant here. When the neural nets add this extra detail in, what they're doing is they're drawing on this kind of huge training set of pictures of a bazillion people. What they're not doing is drawing on any of the data that's relevant to the person you want to see, whether it's that person or not. So don't use this for law enforcement. This is horrible for figuring out if the person you think you see is the person you see. And much worse, the heightened reality of the image gives you a false confidence in what you see, because really the image you've got, the actual factual data, is this pixelated one. And whatever's added onto that is added onto it by the AI algorithm from people unrelated to the person in the image. And there was a great example of this that really struck it home for me, which was a pixelated photo of Barack Obama. And if you saw it pixelated Barack Obama, he's still quite identifiably Barack Obama. And then you run it through the AI image and it turns it into some other dude entirely who you'd never mistake for President Barack Obama. And that's just the point here, is that it gives you this incredibly good-looking photograph of the entirely wrong person, where a human would look at that original pixelated one and would go, yeah, that kind of looks like Barack Obama, but I'm not 100% sure because it's so pixely. But if I were guessing, I would totally guess that that's Barack Obama. Whereas with the outcome of this is there's no way in heck that's Barack Obama. Anyway, the whole evidentiary use of this is an absolute disaster for law enforcement and just shouldn't be done. But that's not the point. The other thing that's really cool is what they're mostly working on this technology for is colorizing old films or despeckling them. Or there's a brilliant example here of a shot from I guess it's from a Paris above ground subway train ride thing in 1890. You should go look at that. It's absolutely marvelous. And because it's a video, what it's able to do, it's not making the image up from nothing. It's upscaling the resolution based on, say, the frames before the frame you see and the frames after the frame. And so this is taken on a streetcar and it's moving slowly through. So you continually get different views of the same objects. And what the neural network's doing is it's kind of putting them all together into a higher resolution version of this. And that's actually totally plausible and really interesting. Neat research. And I was totally stoked to see the researcher who did, I think he actually did the Paris one. I'll have to go check. Denis Shirayev came in and gave his comments on this. And he said, yeah, this isn't giving you the original. It's giving you something that looks better, that's like the original. And so he's very careful to say this isn't a restoration at all of these old movies. It's more like an enhancement. They're just upping the resolution and making it look, snazzier to our modern eyes.
Jenny List wrote an article this week called Amazon Sidewalk. Should you be co-opted into a private neighborhood LoRa network? Which is a good question. So let's unpack this a little bit. Elliot, this Amazon Sidewalk is a product that was announced that is an opt-out, which means it's set up so that your devices that support this are already going to be in this mesh network of other devices in your neighborhood. And you have the choice of opting out. A lot of people are crying foul about that, which we can get to in a second. I guess the idea here is that if you have a bunch of connected devices, let's say it's a security camera, and that could mean like the Ring doorbell or other devices that Amazon sells, you might want them to work even if the internet is down. And so if another device somewhere nearby, whether it's in your house or in a neighbor's house or whatnot, has a network connection, they would share like a low bandwidth kind of heartbeat version of the connectivity with the other devices. What do you think about that, Elliot?
I'm totally torn. I'm glad you mentioned the opt-out nature of this straight out of the gate, because I think that's absolutely the wrong choice. I think just saying, okay, y'all, we're going to enroll you in this, and now your devices are going to do something that they didn't do when you bought them is, that's kind of deceptive, and they should do it the other way. They should make it so that people who want to join this can join it. But I also understand why they did it, and that is that the more people who are in this mesh network, the better. And I have to say, networking is one of those things where there is a peak load problem. That is, you really want the bandwidth there when you want it, but most of the time you're not using it. And so it makes sense for it to be kind of a pooled resource. I'm also a big fan of free and open Wi-Fi networks. We have one here in Germany called Freifunk, and they share routers. You can put up a Freifunk router in your house, and it just broadcasts open free Wi-Fi. I think that's a great idea to provide this kind of service, this kind of shared resource using. I wouldn't force it on anyone, which Amazon's kind of doing. I don't know. Jenny looked into their security model and it looks pretty good. So I'm actually a little bit less sketched out by these devices sending it across your neighbor's internet connection versus your own internet connection. I don't think that really matters that much.
Well, in an altruistic world, this is great, right? Like you said, free and open internet everywhere you are. You don't need to worry about it. It's wonderful. And so if this is done well, like it doesn't stomp on someone's bandwidth, it doesn't allow you to do things that you ought not be doing on someone else's network. It's not open so that the data can be misused by someone that's not authorized. If all those things are solved, it sounds great. But I think to assume all those are solved is a high order. And I guess the other one comes along like, do you trust Amazon? And if you're putting these in your home, then maybe the answer to that is yes, and it doesn't matter
already.
Yeah. So, but the other thing is like the general public that are using these, do they have the technical background and the deep understanding to make an informed decision on whether to trust Amazon with their data or not?
Oh, I think they're doing it anyway. I don't think you can stop them. I think, don't get me started on this rant. I can't do it. I can't
do it anymore. I've done it too much.
I can't. I don't.
Yeah.
No, I think there's also a security issue here that is interesting. It definitely opens up the attack surface of your home network. If you assume that these Ring devices are on your internal Wi-Fi, and then they're also talking this LoRaWAN to all comers who identify as Amazon devices from the outside world, that is a way into your network. And the fact that Amazon is actually letting a whole bunch of third-party providers write apps for this thing means there's a whole bunch of ways that they can make security mistakes that will make this a route for compromises of your internal home network. On the other hand, LoRaWAN is, a couple kilometers of radius. So if somebody wants to bust into your house this way, they're going to have to drive up and do it. It's not like you're exposing a network service on the internet. You're exposing it to your local neighborhood. I mean, it's definitely a security risk. I definitely see how you could worry about that. I think it's kind of a minimal one. I'm not a real security guy, though.
One of the things that I think is important to realize about this is not every one of these devices has the LoRa radio in it yet, but that could change in the future. I also, we started with it. I want to end with it as well. This opt-out feature is bad. And one of the reasons it's bad is because a lot of people will not know that feature is being used. If you had to opt into it, if you had to decide to turn it on, that means someone in your household knows that's been turned on. And if you're having problems, something's fishy, something's going on, or you just hear about on the news that there is a security breach dealing with the system, at least someone will know that it's been turned on. But otherwise, you just have kind of like this old IoT problem that you go back to is like people put something on the wall, they forget about, they don't know that it's there, they don't know what it does. And if there's a problem down the road, how do you as a society go and fix that? Because people have to know like, oh, I have a botnet thing in my house. And so opting into these is, like you said, just one more of those security holes that adds to that problem rather than helping solve it. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us. So if you've done something cool or you see something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. I have a couple awesome questions.
Oh man, why did I do that?
All right.
And I was out of order. No, you're out of order.
I like it.
I can't believe I spelled diaphragm right on the first try.
Do.
This is episode 90. Whew. I was talking to Tom about this. I got a barking dog. Hold on a sec.